In this video, we're going to see how we can use matrices to represent transformations of points in a plane. The first rule is that if we want to find the image of a point xy using a matrix, then we must write the point as a vector. So if I have a matrix 3, 0, 0, 1, which I've represented by T, to find the image of any point xy, write it as a vector, and then we just multiply the two together. So we get 3 0 times xy, 3x plus 0y. 0, 1 times xy is 0 times x plus 1 times y. So any point xy becomes the point 3xy. Let's suppose we take the point A, 1, 2. This will become the point A dashed. We multiply the x-coordinate by 3, the y-coordinate stays the same, and so A starts at the point 1, 2, and is mapped onto the point 3, 2. Let's take another point. Suppose we take the point B at 2, 1. B dashed goes to 3x, 3 times 2 is 6, the y-coordinate stays the same. So B starts at 2, 1, and it's mapped onto 6, 1. Well, let's do one more point. Let's suppose we take the point C at -1, -1. 3 times the x-coordinate is going to give us -3. Leave the y-coordinate alone. So we have C at -1, -1, and that becomes C dashed at -3, -1. What we should be able to see on this, if we look at the diagram, A has been stretched from the y-axis a factor of 3, B has been stretched by a factor of 3, C has been stretched by a factor of 3, and so in this case, we would say that the T represents a one-way stretch parallel to the x-axis of factor 3. Okay, let's have a look at another example. Here I have the matrix 1, 0, 0, -1. And if we multiply xy by 1, 0, 0, -1, I've already done it, we see that we get x minus y. Well, let's look at one or two points again. If I start with A as 3, 2, that will become x-coordinate remains the same, and the y-coordinate becomes minus what it was. So if I start with A at 3, 2, it is mapped onto A at 3, -2. Well, let's take another point. Suppose I start with B at 5, -1. This is mapped onto x stays the same, 5, and y becomes minus what it was, which is 1. So if I start with B at 5, -1, that is mapped onto B dashed at 5, 1. Let's take a third point, C at -3, -4. Looking at the equation, x stays the same. Y becomes minus, which is then +4. So C was at -3, -4. And C dashed is at -3, +4. Just looking at the diagram, we should be able to see that this is a reflection in the x-axis. A reflect, B reflect. I didn't put a dash on. C reflect. So we have there a reflection in the x-axis. T is a reflection in the x-axis. Okay, we've got one more example to look at. Let's see if we can find it. There it is. This time I've got the matrix 0, minus 1, 1, 0. If we multiply those together, we'll get 0 minus 1, that's 0x minus y. So that's just minus y, 1x and 0y. So in this case, the point xy becomes the point minus yx. So if I start with A, is the point 4, 1. This is mapped onto A dashed is minus 1, 4. Minus the y coordinate, and the x coordinate appears at the bottom, minus y, x. So A is at 4, 1. A dashed is at minus 1, 4. Okay, let's try B at minus 5, 1. This will be mapped onto B dashed. The first coordinate is minus the y coordinate, minus 1, and the second coordinate is just the x coordinate. So if that is x, y, this is minus y, x. So B starts off at minus 5, 1, and B dashed is at minus 1, minus 5. Well, let's take one more point, then we might be able to see what's happening. We might still not be able to see what's happening. Let's try the point minus 1, minus 3. That will become the point. The top coordinate is minus the y, so that's 3. The bottom coordinate is just the x. So if I start with C at minus 1, minus 3, that becomes 3 minus 1, C dashed. Well, have a look at that diagram. Can you see what transformation we've actually got at the moment? Not as obvious as the others. This might help. I'm going to draw a line from the, I hope I am, I'm going to draw a line from the origin to A. And I'm going to draw a line from the origin to A dashed. Can you see what's happening a bit there? Okay, let's try and help you a bit more if you still can't quite see what's going there. Let's draw a line from the origin to B. And we'll also draw a line from the origin to B dashed. One more. Let's take a line from the origin to C. I could have chosen it in a better place, I suppose. And a line from the origin to C dashed. What you should be able to see with each of these is that the line OA, if you rotate it 4 along, 1 up, 4 up, 1 back, rotate it through 90 degrees, it ends up on A dashed. There's the secret. If you take OB, rotate it through 90 degrees, it ends up on OB dashed. Take OC, rotate it through 90 degrees, we get OC dashed. And so this transformation comes out to be a rotation through 90 degrees, I can't spell, about the origin. And if I just say a rotation through 90 degrees without specifying which way, mathematically, I will always mean anti-clockwise. So you've seen 3 examples now of a matrix being used as a transformation. These transformations are called linear transformations. Don't worry too much about that name. The book has a more abstract approach to what's going on, but what I have done will give you a good enough understanding for this course.